Now, not to confuse the issue too much, but it turns out that y equals x isn't really the asymptote. It's something close to the asymptote, and when you're far away from the origin, it doesn't make a lot of difference. But when you're drawing the beginning of the asymptote for fairly small values of x, there is something that makes a difference. So we're going to make this more precise. This isn't a bad attempt at the graph, and I would certainly accept it for full credit, but let's just make sure we understand what really goes on here. So we're going to do one more little bit of analysis, reconstruct the graph, and make it a little more accurate. Recall that our function can be written this way in expanded form. And the expanded form does have one advantage over the factored form in that we can look at the asymptotic behavior a little more accurately. Okay, so we have y equals x cubed. Well, I'm not going to read it to you. You know that this is the expanded function. The degree of the denominator is less than that of the numerator, so it makes sense to do a division of the denominator into the numerator and see what we get. Well, I'm not going to go through the division. I'll kind of point it out as I go, but you should by now know how to do long division. Whether you do or not, x squared goes into x cubed x times x squared gives you x cubed, so when you subtract here, you're going to get 0. But of course, you've also got to subtract off x times 5x, which is 5x squared, and x times 3, which is 3x. So subtracting 5x squared from negative 3x squared, that's the same as adding negative 5x squared. So we get negative 8x squared. Subtracting 3x from negative 13x, we get negative 16x. Bring down the 15, and now this goes into this. How many times? Well, negative 8 times. Negative 8 times x squared is negative 8x squared, so when we subtract, this goes away. And then we're going to have a negative 40x and a negative 24. Subtracting negative 40 is the same as adding 40, so this subtraction gives us 24x. Subtracting 24 is the same as subtracting negative 24 is the same as adding 24, so we get the 39 here. And now our long division gives us x minus 8 plus this remainder divided by the divisor. So now we see that y equals x minus 8 plus 24x plus 39 over x squared plus 5x plus 3. Now, what does this tell us about the graph? Well, it tells us that when x gets really large, of course, this is going to get really small because you have only a x first power of x up here, you have a second power of x down here. And just because you got a 24 in front of x doesn't mean that x squared isn't going to beat the heck out of this numerator when x gets much bigger than 24. So if you let x equal 1,000, you're going to get 1,000,000 here and only 24,000 here. And that's clearly going to be approaching 0, and if x gets even larger, this is going to be even smaller. Now the x minus 8 then is going to be the actual asymptote, not y equals x. For very large values of x, that's not going to make a hill of beans of difference. X minus 8 is just pretty much the same as x. If x is 1,000, then this is 992 instead of 1,000. That's not going to be a big difference. If x is negative 1,000, well, same idea. So we look at this function now as this, which is what's going to happen for large x, and this, which is going to give us the same vertical asymptotes that we had before because the denominator is still going to be 0 at the same values. And these are going to combine in some mysterious way that gives us the zeros that we had before. Since this function is the same as this, the zeros of this are going to be the same as the zeros of this whole thing. So it's not going to affect the zeros or the asymptotes, or the vertical asymptotes, places where the denominator equals 0, but it is going to slightly affect our slant asymptote. Our oblique asymptote is going to be y equals x minus 8 rather than y equals x. You should proceed to construct the graph using the same information we had before, only with the additional information that the asymptote is y equals x minus 8 instead of y equals x. And you should see how that modifies slightly the graph. It won't do a great deal to the overall shape of our graph, but a couple of things are going to change. So you should do that. Okay, hopefully you've done that. I've got our zeros, our y-intercept, and our two asymptotes, and our indication of left or end behavior at the right and at the left of the graph. And the only difference is that our asymptote's x minus 8 instead of y equals x. So put the y equals x in here. That was great. But y equals x minus 8, well, where's that going to be? That's going to be the y equals x graph shifted 8 units down, meaning instead of going through the origin, it'll go through the x-axis here. So let's just attempt to draw that. Well, let's see now. If fx equals negative 8, 8's going to be over here. So put this to some reasonable scale. The graph is going to go off something like this. And the graph, the curve is going to come up from negative x values, and it's going to come up either, as we said, on this side of the asymptote, and you can figure out how to determine which side it comes up on. I'm just not going to tell you that. I'm going to let you think about that. And if you don't worry about it. Yeah, or it comes up from here and maybe just goes straight on down. Not straight, but asymptotic. And then over on this side, it'll come through the asymptote just as we said it would. And it'll do this. And it's going to have the same behavior here. It's going to come up through here. And then it's going to have to curve around so that it can eventually become asymptotic to this line. And not necessarily in the scale that I've drawn here, but you get the idea. Now, the only difference between this and the previous graph is basically that this is going to approach the asymptote most likely from above. Again, we're not going to go deep enough into the analysis to see which. Not that difficult. You can figure it out. You might be able to figure it out if you're inclined. And if you want to ask me, I'll be glad to respond. And down here, it's either going to be like this or like this. This is considerably lower than it was drawn on the previous graph. You can look back to the previous graph, which is on this clip near the beginning, and make the comparison.